Okay, good afternoon. Thank you all for coming. So we'd like to talk to you now about early detection of quality problems. This is an area we've been quite involved with in Japan over the last few years. We're helping them through some of their challenges around pushing the quality limits a bit higher than where they are. So my name is Bradley Ford. I'm from Yokogawa, Japan, in our headquarters operations. I've been there for 5 years. Before that, I was based in Yokogawa, Australia for quite some time. So thank you all for coming. Let me first of all start with the industry challenges, some of the things we've been seeing both in Japan and also generally in various places around the world. The first is a lot of emergence from, or upcoming increasing challenges from the emerging market. When you look at the chemical industry in particular, you're really looking at 3 countries that are known globally for quality: Japan, Germany, and the US. Yeah. These are really the best of the best. But what we're seeing, at least on the Japanese side, is a huge challenges now coming from the emerging markets, particularly obviously for us seeing them coming in through India, China, Taiwan, and the associated markets in that Asian region. But also we're seeing it's more difficult than ever to maintain those really high productivity levels combined with sustaining the quality or increasing the quality. And there's a number of reasons for that. First of all, on the consumer side, the variability and the volatility in demand is increasing. Yeah? People want newer devices, new gadgets, or new objects faster than ever before, which for us as manufacturing organisations means we need to also move faster to meet that demand. More complex patterns of customer demand as well. How this is happening, we haven't seen happen before. And then finally, rising expectations. They expect things to have a smoother, cleaner finish, that little bit faster. We saw recently a major smartphone manufacturer had some significant quality issues, yeah? This is a perfect example of, as a consumers, pushing manufacturers to do things faster than they have before, maybe before they're even ready to do it, yeah? Which is causing some of these problems. So we're in a tough situation. We have strong competition really pushing us now, and their consumers are really changing the game. So from Yokogawa perspective, when we really look at the chemical industry, we really see 5 key areas. First of all, efficiency, yeah? Making sure we can do things at a reasonable cost. Reliability, so we can keep operating continuously. Safety, obviously we don't want to hurt our people. Human reliability, yeah. Trained competency versus their actual competency. And finally, quality, yeah. Chemical industry quality is one of the key drivers. So this presentation is really focused around what can we do on the quality area. Yeah. So I want to give you 2 examples. The first challenge we've been seeing is around unknown quality variants. Yeah. So we're quite used to having our heavy equipment, having a particular fluctuation rate in terms of its accuracy and consistency. For a long time, we've had quite stable customer quality specifications. Yeah. So everything's been quite clear and simple. But slowly things have been changing. We're seeing this in Japan through the lack of heavy industry investment. Our equipment, the variability or consistency of the product is now actually increasing. We're having more and more trouble to get that consistency of product quality. The challenge is that that's combined with these customer demands on quality becoming even tighter. So we're having equipment that is becoming a little bit less consistent, combined with customer demands that expect even higher levels of quality. These are opposites, yeah? So it's a really tough situation we're facing. The next thing we've been seeing in Japan is what we call a silent change, yeah? This is changes that are impacting us that we have no idea about. We haven't done anything wrong, we've done the exact same thing. But for some reason, something's changing. Let me give you an example. You're producing on the far right here. You're buying from one of your suppliers, yeah, intermediate products or raw materials. You've had this arrangement for a long time. and you have nice contracts in place that says, okay, you will produce this much, you provide that to us, and this is the specification you provide that to us in. As long as you meet these requirements, we will accept that product, yeah? But for some reason, we've been observing that some of our customers are producing their product exactly the same way, the procedure is executed exactly the same staff with the same level of competency, but for some reason, the quality changes. And in some, we've seen they don't actually know why in some cases. Some of the customers can find the problem. Others are struggling to find where that root cause was, why they've gone from consistently on grade to sometimes on grade, sometimes off, sometimes down specifying their products. As we looked into the problem, working with our customers, we found that actually occasionally the upstream suppliers are changing the composition, or they're downgrading the specification of their product. Maybe they've been producing it for 12 months, and all of a sudden they bring that grade of product quality down. But they're still meeting the minimum requirements that our procurement department contracted with them. So legally, they're doing the exact right thing. As a company, they are doing a good decision. They are finding ways to optimize their production within their contractual constraints. But that's now starting to impact us. So in some other cases, we actually observed where it's actually been 2 or 3 levels up the supply chain, these changes are occurring. So we call this a silent change because we don't see any of this. All we see is that sample inspection sheet that says everything is okay. But it is starting to impact us. Let me give you a little bit of a story about Japan. So I've been living in Japan now for 5 years. I moved there 1 year after the very large earthquake that I'm sure you're all well aware of. In the Japanese manufacturing sector, they've had very strong, very close, tight-knit relationships that cover years and decades. Yeah? So the trust is very, very deep. When they work on a new product together, or on a new product, they do that together as a team. Yeah? So the trust, the consistency is there. They believe that they will never change anything. This change would never happen without any forewarning or advice. Even though it's within the specification, they would still have that discussion. Yeah? Then the earthquake happened. Some plants shut down, never to start up again. Others shut down for a number of years until they could be rebuilt. Yeah? That changed their relationships. They had to now buy from other countries, other companies, places where they didn't have these relationships. The rules of the game around how contracts worked and how the contracts are treated, how relationships work and relationships are treated, are different. Yeah, it's now cross-cultural. Things changed, and now Japan has been struggling with this problem where they don't have that long-term relationship to rely on to ensure that they always get this quality. So they've been facing this challenge of the silent change when they're importing product from various countries, and their upstream providers are doing their best business decisions to optimize their business within their contract. But it's now affecting them. So we've been working really closely with the Japanese chemical industry to find, okay, well, what can we do? Assuming we can't change the contracts, what can we do to solve this problem and at least get some insight into what's happening so we don't have that batch-wide problem in the corner? So when you look at an area to try to solve the problem, well, first of all, we could solve the problem in the supplier area, but you probably all work with procurement departments and legal. It takes a long time, yeah? We're working in the real world. We have product coming in every day. We need to get producing. So we can't really change it at the supplier level. Changing it at the end product level is too late. It's a waste of time, yeah? If the product is off specification, well, it's off specification. So we're downgrading it or we're scrapping it, maybe reprocessing. So we need to do it in the processing phase. The methodology we typically use is what we call a 4M. We first of all look at the machine. Okay, well, our asset's doing well. We know they're aging. We know that'll have an effect on production. Is that the problem? Or is it materials, a variance in the quality of the materials, or even, as I mentioned, the silent change? In some cases, we see the procedures, the SOP. Has there been a change in the SOP? Or has there been a non-compliance of execution of that? And finally, capability of people. Again, this is a challenge we have a lot in Japan, where our workers have gone from being operators with us for 20 years to now being part-time or casual workers who maybe stay for 6 months, 12 months. So their skill and knowledge of our production is actually a lot lower than what it used to be. Toyota's an expert at this. I'm sure you're all aware of Toyota's really good expertise at quality. Yeah. They invest a significant amount of quality, of time, doing evaluations and checking at every single stage of their production, and then a very detailed investigation at the end. They one of the best at the best. But they spend a lot of money and a lot of time, but also they have the opportunity to do the checking at each phase. In our industry, we don't always have that opportunity. Or when we do, it's already too late. So how do we move from finding out the problem here where it's too late to trying to spot the problem a little bit earlier where maybe we can intervene and try to save that batch, bring it back on spec, find what the root cause was, and solve that into the future? We looked into this a lot in the Japanese industry and trying to see what we can do, and we found that most of the technology had a lot of false detections. Yeah? And if you have too many false detections, the operator loses trust. Yeah? You've all worked with operators. If it's not consistently accurate and reliable, they will ignore it, or they'll turn it off. Yeah? In some cases, we found a lot of abnormal events were continuously occurring, and they're occurring at a rate that the operator couldn't respond. He only has so much time and capacity. We found quite a few customers where they didn't know all of the key variables that would affect their quality. They thought they did, but maybe that was only 80%. And there was a couple of hidden parameters that they weren't aware of that actually had a significant impact. But the key one for me is at the top right-hand corner, lengthy root cause analysis time. Most tools and techniques require engineers and data scientists to crunch the numbers in the background, go through all of that, then solve the problem. That's fantastic. But the problem is by the time they've finished, the batch is already finished, and we've lost the batch. We need to do things in a time where we can enable the operator to intervene, yeah? Empowering the operator to do something. We looked at the complexity of what was actually going on here and why people haven't been able to solve this. Is first of all, data analytics is hard. Yeah? How many companies have data scientists in their organization? Some of the big guys do, but a lot of companies don't. Yeah? We have a lot of control engineers, we have IT engineers, but data scientists are not that easy to come by or justify. But data scientists can't do it to solve the problem on their own. You've all seen this. Data is one thing, but what happens on the plant floor is often something else. Yeah? You need to interpret the numbers to understand what is going on. So getting those two to work together is really quite key. Lack of experience or knowledge of the process, as I mentioned, turnover is getting higher. But finally, this point is interesting for me. Cross-department implementation. Quality covers the whole organization. Yeah? Automation, engineering, maintenance, operations, laboratory, purchasing, warehousing. Every single area of the organization is somehow influencing quality. Yeah? So to really solve this problem, we need to bring all the organization together. That's really tough. To do it in a time frame where the operator can actually respond. So how do we get something, or the technology that we've seen is, it's not really enabling the operator. We get these great tools that we can analyze with, but they're so complicated that no one uses them. So what we've actually been doing, and I want to share a little bit about the technology we've been developing. So we've spent quite a few years now working on this with the Japanese industry. And in those years, we've actually developed quite a nice comprehensive methodology, of processes of how to go through improving quality, the steps and approaches to take. We went through and developed a suite of analytical technologies, both for the back-end engineer, but in a way to enable the operator to make a decision. And we know that everyone can't get data scientists, so we have a whole team of data scientists in Japan. They've built the technology in a way that any of our global APC engineering teams can take that, work with the customer, and actually start to optimize the processes. That approach we take, again, we use the methodologies, the people, and the technology in conjunction with that 4M approach, man, machine, method, material, to go through, first of all, through the analysis phase, collecting the right data, categorizing that, processing that, choosing the analysis method, and that post-processing, some of that cleaning. After that, we can really start to pin down where are those root causes of the quality problems, summarizing that, doing a physical walkthrough before we give the results. But I really want to drill down on this a little bit more. So let's step through each stage of that methodology. I've got a nice, a dartboard or arrows here to give you an example. Green is on spec, red is off specification. So the first thing we actually really start doing is getting rid of those false detections. We want to make sure that the data we're working with is reliable and solid. So we spend a lot of time at the beginning really making sure that working with the quality control team to eliminate those false detections. I'll show you an example of that later on. We then next move into detecting some of those abnormalities. Okay, well then when we do go off specification, what is occurring? What are some of the root causes behind that? So then we start to only have on-specification product. The next step we go through is suppressing the variations. So we're always hitting the same point on the dartboard. We don't care where it is, as long as it's the same point on the dartboard every single time. Then finally we start to really push that point as close as we can get to the bullseye, right in the middle. If anyone's done advanced process control, it's quite similar. You stabilize the process, then you push it to the limit. Finally, so once we have the plant running quite well, we're quite happy with this, then we start to run online. We hit the bullseye every single time, because now we're at the stage of really enabling the operator, giving him this information in real time. So as soon as something does start to drift, we say, look, we think there's a problem occurring. These are the areas that are indicating that to us. So maybe you should have a little bit deeper look. Here's an example. You can see some process data. I'm sure none of you can actually see where the abnormal or where the little bit off-track area is. It's impossible, Actually, you can see the caution point was here, the abnormal point was there. You couldn't see that from normal process data. And this is what nearly every operator looks at as something like that, Actually, this is real data. Through the technology we've developed, we convert that into this. This is actually the process data, the quality data that maps to what we're seeing at the top there. It's very simple to see. We know that this is what we call a Mahalanobis distance of about 7.8. We know this is a Mahalanobis distance of about 14. We can see that back here, we're starting to drift off track into an area that we think is abnormal. But actually, we show that to the operator in a specific user interface where he can see the batch process, he can see the quality trend over time, and then he can click on the points in that quality indicator to say, this is what we think the root causes of that problem are. So we're converting highly complex data into something that's very simple. You don't need to really concentrate deeply, but you can quickly identify where the problem is, or the rough area where it is, then allow the operator to use his knowledge and his expertise to really precisely find that and hopefully resolve in a reasonable time. So the technology we use here is called Mahalanobis Toguchi. Yeah? It's a specific analysis method for quality optimization. Originated in Japan. And you can see here what we're actually doing is a type of pattern matching. Here you can see some of the registration data we used for the number 6. Every one of those looks pretty well like a number 6, yeah, roughly speaking. What about the next row? Do they all look like a number 6? No? Any thoughts which ones are 6 and which ones aren't? Only one 6, which is this one? Is that a 6? That's a 6? That's a 6? No. So this technology we're using has converted that to a number and it said, well, this is 3.47. We think that's pretty correct. 3.3, 2.8. That's all below 7.8, so we're happy. 31.4. That's a problem. We know that's out of the optimal operating range. Actually, this same technology is being used by JAXA in Japan, so the Japanese Space Agency. They have a rocket called the Epsilon rocket. They've been using the same technology to do their quality checking. And you can see they used to use 100 inspectors, I think 42 days, and a significant amount of money. After they started using this technology, they dropped that down significantly. 100 people to 8. 7-day inspection cycle. That's quite a significant reduction, yeah? But what we tried to do, and as I mentioned at the beginning, we tried to make this quite practical, yeah? Not every company should need to have a data scientist. So we tried to get our data scientist skill and knowledge, embed that into the software. So if you're an APC engineer, you can sort of take this and utilize it within the facility, or we have actually a whole team that's ready. But also what we found in the chemical industry, there's a lot of secrets. You know, companies have a lot of their own IP that they don't want to share. They don't even want a third-party company to get involved in the analysis at all. So what we actually added as well, embedded in the automatic processing cycle, was MATLAB. So you can also build your own MATLAB logic and your knowledge, embed that in there, and add that into the software. So in terms of our standard processing cycle, you can add your unique knowledge to that at the same time. So to give you some examples, so we have a full team, as you can see, globally that can really support and help do the consulting. We do a lot of work in Japan with this team, helping the Japanese industry. We launched the product 3 weeks ago, but actually we've been working with the industry in Japan for the last 2 years on this technology. So now we've actually had over 120 Japanese projects underway. Most of those are still ongoing in terms of under operations. But what's most interesting to me is of the top 10 chemical industry companies in Japan, 80% of those have already been using the technology to improve their quality. Yeah? So when you look at the top 3 countries in the world, it's Japan, Germany, and the US. We've only been selling this in Japan so far, and most of the best companies have already been utilizing this to improve their quality. Yeah. So we go through this process. Obviously, first of all, you can't just look at data in isolation. You need to understand the process you're trying to analyze, yeah, like anything. Then we go through the analysis process, and then we start to do an evaluation with the customer. We work together to understand, okay, well, this is what the process is doing, this is what your operators are doing, and this is what we see in the data. Let's now evaluate, see what we can do to improve some of those processes. Again, it's really built around that 4M. Man, yeah? What are they doing in the steady state? What happens when things go wrong? How do they handle that? What do they do that's unique when things go wrong? Machine, how's the reliability and consistency of production been in terms of our equipment? Methodologies, are our people executing SOPs consistently in the same way, yeah? And also in compliance with the SOP? And finally, they're the material. As I mentioned, the silent changes that we've been seeing in Japan is primarily in this material area where things are coming in that are different than what we had seen in the past. So The data analysis phase, we actually bring in the process data, so from the data historian or some other source, but we also bring in the quality data from the lab. We want to know which batches were produced at which time range. What was the result of those batches? Were they on specification? Was that the golden batch? Was that close to the golden batch? Or was that something that was a lost product? Then we start to go through that comparison phase of really comparing, well, what is good and where have we had some of those failures in the past and what were the root causes behind those failures? You can see an example of that. So we have our trend data with our alarm, but it's too late by then, we've lost the batch. But we also add that quality index that's giving us a little bit of early insight to where when that problem is occurring. And finally, the indicators. This is where we think the problems are occurring. So just let me get some water before I lose my voice. So we look at the benefits here, what we've actually been seeing in Japan. First of all, they're achieving their quality targets. Yeah, this is obviously the most important one now. But also what we've been seeing is interesting is they're building their customer credibility. Their customers have actually been quite happy that now they're always achieving target. Yeah, the potential for products coming in that are lower grade than was expected has been reduced. So their credibility as a supplier has increased. Again, removing a loss, and in some cases also improving process efficiency. So I've got 3 cases here I want to go through before we finish and have some questions. So the first one was a steel company. So they were having some problems where in the steel sheets, as they're running through the production line, sometimes there was some vibration and they would get a scratch, you know, and then that reduces the product grade, you know, because it's not a clean sheet anymore. So they went through and they thought, okay, let's put in some fast Fourier transform technology to actually try to understand what was happening, what caused these vibrations that resulted in the scratch. Yeah. But they were getting a huge amount of false positives. Yeah. They were getting so many false positives they actually totally ignored this system. And they had people walking out in the line continuously checking everything because it's the only way they could guarantee they'll get the result. So we had some discussions. You can see here actually the good quality data, the bad quality data. You're looking at about 25–30% there as bad or false positives. You can't trust that. So we worked together. We applied our data analytics software on top of this. We eliminated the false detections. And then I think every single time when there was a warning from the false Fourier transform, it was always correct. Because we added the process data plus the results of this together using our technology, the Martin-Lobis technology, and we're able to get the consistency. This enabled the operator then that they were able to make the decision, if they wanted to now no longer require people out in the field to do these manual inspections. Actually, they didn't decide to do that at the time because of various labor reasons, of course. But from a technology perspective, our confidence level was so high they could actually make that decision. So the next one here was plastics. So here again what they were seeing was a purity decrease as they were going through the production process. Again, they couldn't find out exactly why, and they couldn't find out that, or they couldn't actually resolve that in time, because the inspection could only be done at the final stage of the production process. Yeah, so it was too late by that stage. So what we were doing, we worked together, we applied the technology, we trained the system based on what we know was some good production quality data. Then we were able to spot what was typically their abnormal or problematic areas that they hadn't seen before. And then since then they've actually been able to reduce a lot of their quality issues. Yeah. So we're giving the operator the indication earlier before things become a failure. Yeah. It's too late at the final stage. The last one here was a BTX process, so continuous drying. Not so much focus on the quality this time, but the same technology. They were having the clogged steam tubes, yeah. But the problem here was they couldn't actually see that temperature outlet reduction in time. You look at the process data that they were able to gather, it didn't show any real indication that there was a problem. So the operator's going, well, it's all fine, no problem here, until it really dropped off. But it's too late by the time he got to here. He couldn't react and resolve this issue. So he applied the technology, and you can see that Mahalanobis distance, that distance from zero, it's quite nice for quite some time, and then we see a significant jump. But if you look at that jump is quite a long way before the temperature actually dropped off. And the process data, you can't really see anything in there, yeah? In this case, actually that was a 2-day period. So our MD was actually showing that problem 2 days before we actually hit the issue. So it's quite a lot of time for the operator to actually step in, go to his process engineers and say, look, there is a problem coming. Can you guys help me make sure we eliminate this before it does shut us down? So why would Yokogawa get involved, and why would he come to us to start to solve some of these problems? Well, first of all, we have a lot of data scientists and APC experts, but we also have a whole operations team as well. You heard about KVC yesterday. They have a whole team of process engineers, operations engineers. So that unique combination of data scientists combined with process engineering and steady state simulation technology. We have a lot of experience now in Japan actually executing these projects, learning with the Japanese industry of how to improve quality, how to spot these problems, and how to advise the operator early of what could go wrong. This unique pattern recognition technology, so currently we're the only people actually in the world utilizing this type of technology in the process industries. Actually, for the core technology here, we have the global unique access to that. We're solving problems that many of our customers cannot solve. Yeah, so we're working on a project at the moment in Europe, and they came to us and said, look, we're having a quality problem. Our customers are complaining, but we have no idea why. Can you come in and help us and support us? Yeah? Bring in some of your experts, some of your technology, and help us work together to actually find what is the root cause behind this so we can get on with making good quality product. And finally, working together. So you probably heard a lot about co-innovation this morning by Yokogawa, and this is very much a DNA thing for us of how we work. We don't do things on our own anymore. We used to in the past. We just worked all by ourselves and we released a product to market, and sometimes the customers didn't even want it, they didn't even care. So now we're working hand in hand. Yeah, everything we do, we develop with the customer. Here, most of the Japanese chemical industry has been involved with us in some way, developing this, testing this, improving this technology. It's the same with everything we do. So the way we work is we work hand in hand. And that's what I would be saying to you guys as well, that we would work together on these sort of technologies. Yeah. It's the only way we can actually really push forward. So thank you very much. If you have any questions, I think I still have some time to answer some questions. Yeah.